Students, today we shall have a discussion in connection with the slaughter mechanisms, slaughter operations, and the difference between the planer and slaughter in continuation with reciprocating machine tools. So now before I proceed with the today's session, we need to understand what we have discussed in the previous session. So in the previous session, we have discussed in length in connection with the size and specification of a planer, main parts of a planer, and what are the planer operations and the comparison between the shaper and the planer. That is what we have discussed in the previous session. And in the today's session, so if you are going to see the construction there, and if you are able to recollect yourself, we need to understand here that the construction of the whatever the operations that we are going to do on a shaper, it is just similar to a slaughter machine. The only basic difference is that in case of a shaper, okay, the ram is horizontal carrying the cutting tool, but whereas the ram carrying the cutting tool is vertical. So that is the basic difference in the construction. So that is how the working of the slotting machine is there. Okay, the remaining mechanisms, whatever which we are going to use in a shaper, the same one is also used in the slaughter or the slotting machine. So let us understand here. First, we need to understand what type of drive mechanism is used in case of a slaughter. Okay, so just like in shaper only, the same mechanisms are used. Okay, that is what we are going to as good as a revision of what we have discussed in the previous session. So in slotting machine, the metal is cut during the upward stroke and no metal is removed during the downward stroke. This is very important. In a slotting machine, the material is cut during the upward stroke. So whenever it goes up, the material is removed, and during the downward stroke is removed and no metal is removed during the downward stroke. So the time taken in the downward stroke can be reduced to improve the working speed of the machine. Okay, that is the main idea here. So the quick return motion mechanism is used to drive the ram of the slotting machine. The ram is driven, how we have discussed in case of a shaper. Okay, the same one mechanism is also used where we require to see that the cutting stroke takes place slowly and the return stroke faster. So such a mechanism we call it as a quick return motion mechanism, because our intention is to reduce the total machining time. Quick return mechanism is used to produce a reciprocating motion in which the time taken in return stroke is less than the time taken in forward stroke. This is the basic idea that, or basic principle, where we are going to consider the drive mechanism of a slaughter. So now let us understand based on the mechanisms. Basically, the slotting machines are also classified based on the mechanisms used. So they are nothing but the hydraulic drive, okay, crank and slotted link mechanism, and Whitworth motion mechanism. So we need to understand here few important basics where these drives are used depending upon the applications of the job, depending upon the characteristics of the job to be machined. Okay, so now we are interested because this is the mechanism, or these are the three mechanisms which can provide us, okay, the cutting stroke slowly and the return stroke faster. So that principle is adopted in all these drives, that is hydraulic drive, crank and slotted link mechanism, and Whitworth quick return motion mechanism. So we need to understand here clearly how the Whitworth quick return motion mechanism works. So as you are going to see clearly on the screen here, just I'll be explaining in brief now. Just observe carefully. We require to first drive the pinion, as you are going to see here. So we require to drive the pinion which is driven continuously, okay, with the help of a motor or a gearbox, whatever is there depending upon the speed arrangement. But we require to see that we are going to give the motion to the pinion. This pinion is in connection with the bull gear. The word bull is used because it is a big gear compared to the gear teeth. The number of gear teeth on the pinion is less, definitely, okay, and the number of teeth on the bull gear is more because of the larger diameter. And at the middle of the bull gear you are going to see called as a crank plate. The crank plate is provided with the help of a crank pin is also there. Okay, so now what is going to happen here, if you are going to observe clearly, okay, then this crank plate is in connection with the connecting rod, and that connecting rod is connected to the ram. So now the movement is going to take place in this way and in this way, that is in a vertical direction only. So our intention is to see that we are going to give the speed or the power starting from the pinion itself. First of all, I require to give the motion to this, then there is a transmission of the motion through the bull gear finally to the ram. So that is how the arrangement or the mechanism is there. So this mechanism is just similar to what we have discussed, okay, in the case of a crank and slotted link mechanism. So we need to understand here the Whitworth quick return motion mechanism generally used in slaughter. So this is a type of mechanism that is the commonly used in case of a slotting machine. An electric motor drives a pinion at constant speed. So this we need to understand. Whatever the speed is there, the speed of the pinion which you are going to see here, the pinion is driven continuously, okay, with the help of a motor which we are not shown. Okay, so now this pinion is in contact with the bull gear. The word bull is used because the number of teeth provided on this gear is a very big one. That is why the word bull is used. The pinion is having less number of teeth. That means suppose if you are going to take the gear ratio, suppose the pinion rotates say about 20 rotations, then this gear will have a movement of only 1, like that. So depending upon the gear ratio. So we need to understand here one important concept, that we are going to provide first motion to the pinion. As the pinion is in contact with the gear, okay, this bull gear will start rotating. So as the bull gear starts rotating, it is going to through the crank, this crank pin which you are going to see, there is a continuous movement of this mechanism. So due to that, the stroke is given to the ram which you are going to see here. Okay, the pinion drives the bull gear. The pinion drives the bull gear at uniform speed. Whatever the speed is there, it should be uniform one. The bull gear has a crank pin C fitted with a sliding block. This is very, very important. The bull gear has a crank pin fitted with a sliding block. So this is called as a sliding block which you are going to see. This sliding block will have a movement within the slot provided. Okay, a crank plate is pivoted eccentrically on the bull gear at the point O by a pin. So as you are going to see, a crank plate is provided. So this is called as a crank plate. This is called as a crank plate which is provided eccentrically on the bull gear at the point O. Just see the difference. At the point O, there is a provision of eccentric on a bull gear itself, on a slot, as you are going to see clearly there. So now let us understand in the next steps how it works exactly. The crank plate has a slot along its length. The crank plate has a slot along its length. So this is the crank plate which is having a slot like this. The crank pin with sliding block slides along the slot of the crank plate. As you are going to see here, the crank pin is there. The crank pin is going to slide along the slot of a crank plate. the other end of the crank plate is connected to a connecting rod through a pin P, as you are going to see clearly there. This is called as a pin P. So now what we are going to do, the other end of the crank plate is in connection with the pin P. The ram is fitted to this connecting rod. So now you are going to have, through the connecting rod, there is a fitting of the ram. So now the rotation of the bull gear will create a motion in either directions to the ram. Okay, the ram is fitted to this connecting rod. It is unlike the crank and slider mechanism. The forward reciprocating motion is slower rate than the return stroke. We need to see that always. Okay, it is not like a crank and slotted link mechanism here. The forward reciprocating motion should be slower. That means this motion, whatever you are going to see here, this motion should be slower than this motion should be fast. That is, the downward movement should be slow and the upward movement should be fast. That is how the mechanism is going to work here. Now how it works, let us understand in detail about that. When the bull gear rotates, as you are going to see, the crank pin rotates about its center. When the bull gear rotates, so how the motion is given to the bull gear? The bull gear will start moving depending upon the motion of the pinion. Okay, when the bull gear rotates, the crank pin rotates about its center. At the same time, the sliding block slides along the slot of the crank plate. This makes the crank plate to rotate about the point O, and thus the rotary motion of the crank plate is converted into the reciprocating motion of the ram through the connecting rod. This working principle is just similar to what we have discussed while discussing about the shaper mechanism. The only difference is in case of a shaper, the ram used to be horizontal, but whereas in case of a planer, the strokes will be like this. But whereas in case of a shaper, you will be having forward stroke, return stroke. Similarly, in case of a slaughter, you will be having the motions in this way. That is the only difference between the two, but the mechanism used is same in both the cases. So this is how it is possible to see that the total time spent in the slotting operation will be less, because the main idea of using a quick return motion mechanism is to see that the total machining time, whether we are going to have the production of the keyways or the production of or the removing of the flat surfaces, whatever is there, so all these operations can be carried out very quickly, provided if all the adjustments are made in connection with the stroke length and in connection with the working of a mechanism. So one important point that all of you need to understand here is the cutting stroke is always slower than the return stroke. So that is how the mechanism is going to function, and all this type of facility or motion is provided with the help of those mechanisms which we have discussed in the presentations. So now at the same time, we need to understand what are the operations that is possible. So as if you are going to compare with the shaper, you need to recollect yourself. The basic difference between the shaper and slaughter is that in case of a shaper, the ram is made to move horizontally, but whereas in case of a slaughter, the ram is made to move vertically. That is the basic difference in the construction, but as far as the application and other things are concerned, almost remains same, including the driving mechanisms. But we need to understand now in detail that what are the operations that are being carried out even on a slaughter machine. Okay, slaughter operations include machining of flat surfaces. So whenever we want to go for the reduction of the height of a workpiece or the reduction of the thickness of the workpiece, then we are going to take the slotting machine. Okay, that is the main objective or the intention of using the operations using the slotting. Machining circular surfaces. Even the circular surfaces can also be machined. That is very, very important. machining internal surfaces can also be done. Suppose if at all I want to go for an internal keyways, even those things can also be produced. Machining grooves or keyways, just I have told, whatever the type of groove and a keyway is there, that depends upon the adjustment of the stroke length and the profile of the cutting tool being used. But in all these things we need to understand here, the main important type of cutting tool that is used is nothing but a single point cutting tool in case of a shaper and slotting machines. So we need to understand that only in case of a planer, the whatever the cutting tool is there is quite bigger, because the planer machine itself is a big one compared to the shaper. So the basic difference we need to understand here, that in case of a shaper there is a horizontal movement to the ram which is going to carry the tool head along with the cutting tool, but whereas in case of a slaughter, the movement of the cutting tool is in a vertical direction. That is very, very important. Now, apart from that, we need to understand here clearly what is the differences, or what are the differences between the slaughter and the planer, because if we are not able to understand, and in some cases in examinations they can ask all the three also, that means compare all slaughter, planer and shaper. So you need to understand, because in the previous session we have discussed in length in connection with what are the differences between the shaper and planer. Okay, we have replaced their planer remains same, and we require to understand what are the differences. Just we are going to compare to efficiency, the movement of the cutting tool or whatever the workpiece, and etc. So we need to understand here we have made two columns there. One, the first column represents the slaughter and the second one is the planer. So in case of a slaughter, as the name, these are lighter, smaller, cheaper machine. So definitely the slotting machine is a lighter one, smaller one and a cheaper machine. But as you know, a planer is a big machine compared to the slaughter. Okay, these are heavier, larger and costlier machines compared to the slaughter. This basic differences may come in the examinations. So you need to study properly. So you need to understand the basic working principle here, because in case whether it is a slaughter or a planer, we need to understand that in a planer the feeding is given to the table. That is very, very important. But whereas in case of a slaughter, the feeding is given to the cutting tool. Okay, though let us go to the next point, low machining accuracy. In case of a slaughter, the machining accuracy is low. So whenever we speak about this machining accuracies, we need to understand that it is only a comparison point of view. Okay, so compared to planer it is, but whereas in case of a planer it can be considered as a high machining accuracy, because whatever the machining operation is there is controlled in a correct way, of course in both the cases. But the comparison makes us that in case of a slaughter it can have a low machining accuracy, but in case of a planer it is having a high machining accuracy. The rate of power consuming is low, definitely, because slaughter is a small machine compared to the planer. Definitely whatever the power consumption is there in case of a slotting machine is less compared to the planer, which is having a high, because in a planer is a big machine compared to the slaughter. Okay, and even the size of the planer is quite big, as we have discussed in length in the previous sessions. So whenever we want to go for the operations on a very large workpiece, then the preference is given for the planers. In slaughter, not possible to take deep cuts and heavy feeds. This is very, very important, because compared to the planer it is a small one. That is why it is not possible to take a deep cuts, and heavy feeds cannot be given. Whatever the feed rate is there and the depth of cut is there has to be in a very small amount, not in a very big amount. But whereas in case of a planer it is possible to take deep cuts and heavy feeds, because basically the construction of the planer itself is in such a way that it is a very big machine compared to the slaughter. And this is intended for small jobs. This is also very, very important, as I have told, because the size of the planer is minimum 3 to 4 times bigger than the size of a slaughter. So that is why we can say that in case of a slaughter it is basically applicable for small jobs, but whereas the planer can be used for the large jobs, can be machined. Okay, so that is why in the previous session also we have compared the shaper and planer, okay, for better understanding about the operations. But we need to understand how the operation is being carried out depending upon the arrangement of the single point cutting tool and whether the movement is given to the cutting tool or the work table. So based on that, these are considered as the different differences or the differentiation between the slaughter and a planer. So now we need to understand, apart from that, what are the frequently asked questions expected to come in the examinations. That is also an important point. So in examinations there is everything that they can ask you. List the various operations performed in the slotting machine. So whenever regarding that, which we have already discussed in length, so we need to write, okay, machining of flat surfaces, machining circular surfaces, machining internal surfaces, and machining of grooves or keyways which are provided on the workpieces, the operations. Enlist the difference between the planer and the slaughter. This is also an important question. So just I have discussed in length in connection with the differences between the two, that is slaughter and planer. But we need to understand whether the difference is discussed in connection with the shaper and the planer or the slaughter and planer. We need to understand the compared to the shaper and slaughter, the planer machine is a big one and used for heavy jobs only, but whereas the shapers can be used for small type of jobs and very less complicated operations, but whereas in a planer it is basically used for the purpose of heavy jobs. So these are the expected questions to come in the examinations. So with this, I'm going to finish off the today's presentation, and all of you note down the whatever we have discussed in the today's session. Even in the examinations there is a likely that they can ask you compare the shaper, planer and slaughter. So we need to understand, because in the previous session we have discussed the differences between the shaper or the comparison between the shaper and planer, but now we have discussed about the planer and slaughter. So we need to understand that the planer is considered as a common in both the cases, and we have compared with the shaper and slaughter. So that is why such questions will be asked in the examinations also. So you need to study in detail about the working principle of the same and try to write correctly in the examinations. So these two questions, just I am telling as a remembering question, that is expected to come in the examinations for 2 to 4 marks, and sometimes they can ask in the examination that explain the construction and working of a slaughter also. So you require to draw a neat sketch, then you have to explain the same. So with this I'm going to finish off the today's presentation, and in the next presentations, so I think that completes the basic in a reciprocating motion. First part is over, that is in comparison what we have discussed starting with the shapers, and in the next presentations we shall have a discussion about the drilling machine as a part of the reciprocating movements. Okay, so with this I am going to finish off the today's presentation. Okay.
तो मैं आपको बताना चाहूँगा कि बीटेक मैकेनिकल स्टूडेंट्स के लिए, पॉलिटेक्निक मैकेनिकल स्टूडेंट्स के लिए और आईटीआई करने वाले स्टूडेंट्स के लिए काफ़ी यूज़फुल है। और ये जो स्लॉटर मशीन है ये आपका मैन्युफैक्चरिंग टेक्नोलॉजी सब्जेक्ट है, उसके अंदर आप इसको पढ़ते हैं। मेरा नाम आदित्य प्रकाश और स्टार्ट करते हैं हम वीडियो। तो सबसे पहले हम स्लॉटर मशीन को देखते हैं। इसके हम इंट्रोडक्शन पढ़ेंगे इस टॉपिक में। वीडियो के अंदर हम ये टॉपिक जो है कवर करेंगे। डेफिनेशन देखेंगे इसकी, टूल्स देखेंगे यानी कि इसमें कौन सा टूल इस्तेमाल होता है, प्रिंसिपल देखेंगे इसके यानी कि किस सिद्धांत पर ये काम करती है, एप्लीकेशंस देखेंगे इसके यानी कि स्लॉटर मशीन क्या चीज़ करने के काम आती है, पार्ट्स देखेंगे हम स्लॉटर मशीन के, टाइप्स देखेंगे स्लॉटर मशीन्स के। तो स्लॉटर मशीन को आप देखिए, ये स्लॉटर मशीन है, एक बार आप इस वीडियो को देख लीजिए। इस वीडियो में आपका स्लॉटर मशीन दिया हुआ है। तो स्लॉटर मशीन इस प्रकार की होती है, ठीक है। इसमें देखिए सर्कुलर टेबल है, कैरेज लगा हुआ है, रैम है, कॉलम है, बेस है। तो आप इसको देख लीजिए, इससे आपके दिमाग में आ जाएगा कि स्लॉटर मशीन होती किस प्रकार की है। नेक्स्ट देखते हैं हम स्लॉटिंग प्रोसेस। ठीक है, तो स्लॉटिंग क्या है? ये एक मशीनिंग ऑपरेशन है जो स्लॉट यानी कि खांचे, ग्रूव यानी कि नालियां और कीवेज बनाते हैं। यानी कि स्लॉटिंग इज द मशीनिंग ऑपरेशन टू प्रोड्यूस स्लॉट, ग्रूव्स और कीवेज। स्लॉटिंग वह प्रोसेस है, मशीनिंग ऑपरेशन, जिसके द्वारा हम इसमें खांचे, नालियां और कीवेज बनाते हैं। ठीक है, ये जो प्रोसेस है स्लॉटिंग प्रोसेस, ये किसके द्वारा किया जाता है? सिंगल पॉइंट कटिंग टूल के द्वारा किया जाता है। यानी कि एक धारी कर्तन औजार के द्वारा इसको किया जाता है। और उसका मोशन क्या होता है? रेसिप्रोकेटिंग मोशन, यानी कि वो आगे जाता है और पीछे आता है। ठीक है, तो ये स्लॉटिंग प्रोसेस किसके द्वारा किया जाता है? स्लॉटर मशीन के बारे में। स्लॉटिंग मशीन के द्वारा ये प्रोसेस किया जाता है। तो स्लॉटर मशीन को देखते हैं कि जो स्लॉटर मशीन होती है वर्सटाइल मशीन होती है, मतलब काफ़ी बड़ी भारी भरकम मशीन होती है ये आपकी। और ये स्लॉट्स यानी कि खांचे, ग्रूव्स यानी कि नालियां और कीवेज बनाने के काम आती है। ठीक है, इसमें क्या होता है? जो आपका टूल होता है वो टूल पोस्ट पर फिक्स्ड होता है। ठीक है, और टेबल जो होता है उसका रोटेटरी होता है, यानी कि आप उसको लेफ्ट टू राइट और राइट टू लेफ्ट अपने एक्सिस पर घुमा सकते हैं। और जो इसमें वर्क पीस होता है वो रोटेटरी टेबल के ऊपर लगा हुआ होता है, वो भी आपका क्या हो सकता है? लेफ्ट टू राइट और राइट टू लेफ्ट आपका घूम सकता है। ठीक है, अब इसमें देखते हैं टूल्स जो यूज होता है स्लॉटर मशीन में वो कौन सा होता है। तो इसमें जो टूल आपका यूज होता है वो आपका सिंगल पॉइंट कटिंग टूल होता है, यानी कि एक धारी कर्तन औजार इस्तेमाल होता है। और वो आपका किस चीज का बना हुआ होता है? हाई स्पीड स्टील का सीमेंटेड कार्बाइड टिप टूल होता है, यानी कि इन दोनों पदार्थ का ये आपका बनाया जाता है। ठीक है, इसका मोशन क्या होता है? यानी कि इसकी चाल जो होती है वो होती है रेसिप्रोकेटिंग मोशन। ठीक है, तो रेसिप्रोकेटिंग मोशन क्या मोशन होता है आपका? कि टूल अपने रास्ते पर आगे जाता है और उसी रास्ते पर वापस लौट कर आ जाता है, तो इसको हम बोलते हैं रेसिप्रोकेटिंग मोशन। तो इसमें जो कटिंग होती है वो फॉरवर्ड स्ट्रोक में होती है, यानी कि जब टूल आगे की डायरेक्शन में बढ़ रहा होता है तो उस टाइम पर ये कटिंग करता है। ठीक है, और इसका जो टूल है ये बिल्कुल आपका किसके सिमिलर है? जो आप लेथ मशीन में टूल यूज करते हैं बिल्कुल उसी के समान ये होता है। जैसे आपने लेथ मशीन का टूल देखा होगा तो सेम उसी के जैसा होता है ये। अब हम इसका प्रिंसिपल देखते हैं, यानी किस सिद्धांत पर स्लॉटर मशीन काम करती है। तो इसमें क्या होता है? आपका जो एक धारी कर्तन औजार होता है वो टूल पोस्ट में लगा हुआ होता है। ठीक है, यानी कि जो सिंगल पॉइंट कटिंग टूल है वो टूल पोस्ट में क्या होता है? फिक्स होता है। और वो रैम में लगा हुआ था जो रेसिप्रोकेटिंग मोशन करती है अपना आगे से पीछे की डायरेक्शन में। ठीक है, तो जो फॉरवर्ड स्ट्रोक होती है वो कटिंग स्ट्रोक होता है, यानी कि जब टूल आगे की तरफ बढ़ता है तो वो कटिंग करता है और उसकी स्पीड कम होती है, क्योंकि स्पीड इसलिए कम हो जाती है क्योंकि वो धीरे धीरे काटता हुआ चलता है। और जब ये टूल आपका पीछे आता है तो उसको हम क्या बोलते हैं? बैकवर्ड स्ट्रोक और रिटर्न स्ट्रोक। ये आइडल होता है, यानी कि इसमें कोई वर्क नहीं होता, कटिंग नहीं होती और ये काफ़ी तेजी से पीछे आता है। ठीक है, और जो हमारे इसमें लेंथ जो है, स्ट्रोक जो है आपका, वो आप एडजस्ट कर सकते हैं वर्क पीस के अकॉर्डिंग। यानी कि अगर आपका मटेरियल बहुत ज़्यादा हार्ड है तो आप क्या करेंगे? उसकी स्पीड को थोड़ा बढ़ा देंगे, और अगर आपका सॉफ्ट मटेरियल है तो आप उसकी स्पीड को कम कर देंगे। ठीक है, अब इसके एप्लीकेशंस देखते हैं कि इसका यूज़ किस लिए किया जाता है। तो ये हमारा बनाने के लिए किया जाता है, स्लॉट्स बनाने के यानी कि खांचे बनाने के, ग्रूव्स यानी कि नालियाँ बनाने के काम, और की वेज यानी कि की वेज बनाने के काम आता है। नेक्स्ट हम देखते हैं इसके पार्ट्स। तो ये देखिए, ये आपका एक डायग्राम है, इसको आप एग्जाम में अगर आपको बनाने के लिए आता है तो ये डायग्राम सबसे सिंपलेस्ट डायग्राम है आपका, इसको आप बना देंगे। ये इजी टू ड्रॉ है आपका, और एग्जाम में अगर आप ये डायग्राम बनाकर आते हैं तो एग्जामिनर देखता है कि बच्चे को नॉलेज है, बच्चे ने मशीन बनाई है। और डायग्राम आप लिखाई कितनी करके आ जाए, लेकिन अगर आपने डायग्राम नहीं बनाया तो शायद आपको उतने नंबर ना मिल पाए। ठीक है, तो ये डायग्राम आप देख लीजिए, इसमें ये सबसे नीचे इसका बेस है, फिर देखिए इससे ऊपर इसका मोटर लगा हुआ है राइट हैंड साइड, और लेफ्ट हैंड साइड में इसमें टेबल लगा हुआ है। टूल होल्डर में आपका टूल फिक्स है, और ये रैम है आपका और कॉलम। तो ये डायग्राम बहुत आसान डायग्राम है और बहुत सिंपल डायग्राम है आपका स्लॉटर मशीन का। नेक्स्ट हम इसके पार्ट्स देखते हैं। तो इसके बेसिक 6 पार्ट्स होते हैं। कौन कौन से? बेस होता है, कॉलम होता है, सैडल होता है, टेबल होता है, रैम होता है और टूल हेड होता है। ठीक है, तो इसके पार्ट्स को हम देखते हैं। जो इसका बेस होता है वो कास्ट आयरन का बना हुआ होता है, यानी कि ढलवे लोहे का। ढलवे लोहे का इसलिए बनाते हैं क्योंकि जो कास्ट आयरन होता है वो आपके वाइब्रेशंस को एब्जॉर्ब कर लेता है, यानी कि कंपन को एब्जॉर्ब कर लेता है, कि जिससे कि मशीन आपकी एक तो साउंड कम प्रोड्यूस करती है और स्टेबल रखती है। ठीक है, वाइब्रेशन होने से क्या होता है कि वर्क पीस जो है आपका तिरछा मिर्चा कर सकता है। ठीक है। तो ये जो आपका बेस होता है, इसमें सारी मशीन का लोड होता है, इसमें सारी मशीन जो है कंस्ट्रक्टेड होती है, और इस पे जो आपको कर्तन फोर्स लगता है, यानी कि कर्तन बल जो लगता है आपका, कटिंग फोर्स टूल का, उसको भी एब्जॉर्ब कर लेती है। नेक्स्ट आपका क्रॉस रेल। तो जो क्रॉस रेल होती है वो आपकी क्या होती है, ये गाइड वे पर लगी हुई होती है। गाइड वे यानी कि टूल जो आपका मूवमेंट कर रहा है, आगे पीछे हो रहा है, या तो ये टूल हेड जो होता है वो आगे पीछे मूवमेंट करता है, ऊपर नीचे जाता है, तो ये क्रॉस रेल पर लगा हुआ होता है। नेक्स्ट है आपका सैडल। तो सैडल ये किसके ऊपर लगा हुआ होता है, क्रॉस रेल पर, और ये टेबल का मूवमेंट कराता है। फिर नेक्स्ट है टेबल। टेबल में क्या होता है, टी स्लॉट लगे होते हैं, जिसपे हम क्या करते हैं, वर्क पीस को क्लैंप कर देते हैं, जिससे कि वो इधर उधर ना भागे, और वो वर्क पीस जो है आपका, वो टेबल के ऊपर रखकर आप उसको डिफरेंट डायरेक्शन में घुमा सकते हैं। नेक्स्ट है इसमें आपका रैम। रैम क्या है, इसका रेसिप्रोकेटिंग मेंबर है, यानी कि ये क्या है, रेसिप्रोकेटिंग मोशन करता है। इस पे आपका क्या होता है, टूल लगा हुआ होता है, ठीक है, और टूल किस पर होता है, इस पे टूल हेड पे, यानी कि टूल हेड हमारा रैम पर लगा हुआ होता है, जिसकी हेल्प से क्या होता है, रेसिप्रोकेटिंग मोशन करके वो कटिंग करता है। फिर नेक्स्ट इसमें आपका टूल हेड। टूल हेड में क्या होता है आपका, जो इसमें आपका टूल जो है वो इसके अंदर लगा हुआ होता है। नेक्स्ट हम देखते हैं टाइप्स, कि स्लॉटेड मशीन के कितने टाइप्स होते हैं। तो देखिए इसमें पंचर स्लॉटर मशीन होती है, प्रिसीशन स्लॉटर मशीन होती है आपकी। तो ये दो प्रकार की आपकी मशीन होती है। तो एक बार हम इसमें थोड़ा कंपैरिजन कर लेते हैं कि पंचर स्लॉटर और प्रिसीशन स्लॉटर में क्या अंतर होता है। तो देखिए जो आपकी पंचर स्लॉटर होता है वो क्या होता है कि ये लार्ज अमाउंट ऑफ मेटल को रिमूव करता है, यानी कि आप कोई बड़ा वर्क पीस है, उस पर अगर आपको स्लॉट काटने हैं तो उसके लिए ये पंचर स्लॉटर मशीन यूज़ की जाती है। तो ये हैवी ड्यूटी मशीन होती है और इसकी स्पीड जो होती है कम होती है। नेक्स्ट आपकी प्रिसीशन स्लॉटर मशीन, ये क्या होती है, स्मॉल अमाउंट में मेटल को रिमूव करती है, और ये छोटे, जनरली जो छोटे वर्क पीस होते हैं उन पर वर्क करने के काम आती है। और ये आपकी लाइट ड्यूटी मशीन होती है, यानी कि हल्की मशीन होती है, और इसकी स्पीड काफ़ी तेज़ होती है कंपैरिजन टू पंचर स्लॉटर मशीन। नेक्स्ट देखते हैं स्लॉटर टूल्स हमारे। तो स्लॉटर में जो मशीन होती है उसमें आपका राउंड नोज टूल लगता है, रिलीविंग टूल लगता है, टूल बीट कटर लगता है, की वे कटिंग टूल लगता है, और आपका पार्टिंग टूल लगता है, ठीक है। अब हम देखते हैं इसके पैरामीटर्स क्या क्या होते हैं। तो इसमें जनरली आपके 3 पैरामीटर्स होते हैं, ठीक है। एक होता है कटिंग स्पीड। कटिंग स्पीड क्या होता है कि डिस्टेंस ट्रेवल बाय स्लॉटर टूल ड्यूरिंग कटिंग स्ट्रोक इन मिलीमीटर पर मिनट, यानी कि इसमें होता क्या है कि जो जितना डिस्टेंस आपका स्लॉटर टूल कटिंग के दौरान, यानी कि फॉरवर्ड स्ट्रोक में जितना डिस्टेंस जितनी तेजी से कवर करता है उसी को हम क्या बोलते हैं, कटिंग स्पीड। नेक्स्ट आपका फीड। तो फीड क्या होता है, द डिस्टेंस मूव बाय द वर्क पर डबल स्ट्रोक एंड एक्सप्रेस इन मिलीमीटर, यानी कि इसको मिलीमीटर में हम एक्सप्रेस करते हैं। और ये क्या होता है कि एक स्ट्रोक में कितना जो आपका टूल है वो कितना कटिंग कर रहा है, कितना मूव कर रहा है आपका, ठीक है। नेक्स्ट है इसमें आपका डेप्थ ऑफ कट। तो ये क्या होता है, परपेंडिकुलर डिस्टेंस बिटवीन मशीन सरफेस एंड अनमशीन सरफेस, यानी कि जो आपके मशीन का जो एक होता है कि जैसा परपेंडिकुलर डिस्टेंस क्या होता है कि एक आपके 2 सरफेस होते हैं, एक जो आप मशीन कर रहे हो उस सरफेस को और जो अनमशीन कर रहे हो, तो उनकी जो गहराई होती है, यानी कि आप कितनी गहराई तक उसको कटिंग कर रहे हो, ठीक है। तो ये भी आपका mm में, मिलीमीटर में आपका डिनोट होता है। थैंक यू फ्रेंड्स, थैंक यू फॉर वॉचिंग माई वीडियो। हैव अ नाइस डे, बेस्ट ऑफ लक फॉर योर एग्जाम। और प्लीज़ हमारे चैनल को
Now we are here to again the series of the lab demonstration of theory of machine lab. So today we will try to understand about the Whitworth Q-Critter mechanism. And the Whitworth Q-Critter mechanism is what? You know that? It's a second inversion of slider mechanism. So this is a diagram of simple single slider gang mechanism. You all know that this is a link 1, fix 1, and link 2, this is called crank, and this 3 is called connecting rod, and 4, this is called a slider. So we try to be compare with these two. So because this is a second inversion of slider gang, so this time we will fix the second link, or this link we have to be fixed, and other are in the mechanism. So let's try to be understand with the help of this diagram. So you know that you can see that this link, this is here, this is a link 1. see that this is a link 1, so this is a link 1, and this link 1 is connected to the slider 4. So this bolt, this is a slider here, so this is a link 4. So link 1, link 4, and link 4 is connected to link 3. So this is called the link 3, or so you can see that this is called the link 3. So we can say this link 3 connected to link 2. So this all elements, okay, so this all elements is, say this is a link to fix 1. So you can easily understand how it is called, why it is called the second inversion, because here link 2 is the fix. So dear friend, you know that this mechanism, application of this mechanism are used in saper machine and cutting hacksaw. Okay, so because when we are removing two materials from one piece, so we require more time, so more material can be removed, and because the return stroke is the idle one, so at that time, so it's required quick return. So that's why it is called the quick return mechanism, because that one is the idle motion of the tool post. And all this, dear student, this is all the arrangement which is connected to the tool post. So it's not a part of this main mechanism. So it's the extra elements which is connected to the tool post. So thank you so much, dear student, for watching the video. And